Hello, my name is Dewey, and today we're going to be doing our second lesson in this video series, which is about loops. So again, opening Python, I recommend rebel.it. If you want something else, feel free. So before we talk about loops in the context of Python, let's talk about what loops generally are in the programming world. So in programming, a loop is basically a structure that you can use to do something repetitively. Now, there are a few types of loops. In this instance, we are talking about a count-controlled loop. It's a fancy way of saying that we have a loop where we know how many times the code is going to run. We know in advance the number of times, the number of repeats a certain function or whatnot will run. Okay? That is why it's called a count-controlled loop, because it is controlled by a counter. So a for loop repeats therefore a fixed amount of times, and it introduces a new variable in the syntax. Now, what is that new variable? Well, in this case, in this example, it's I. In the context of Python, for I in range is one of the most common statements we make when it comes to creating a for loop, because I is the most common variable we use for for loops. Why? There are many reasons why. I is just something that people have come to use colloquially, but you can use any variable you want. You can do for number counter, for x. It can be any variable. The I doesn't matter in this case, the I variable name. It can be anything. Okay? It's just a counter for the number of times we run a piece of code. Now, what's interesting, though, is if you look at this slide, is that the number of times hello world is printed, which is the code indented and therefore placed inside the for loop, isn't actually 10. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. But wait, in our for I in range, we are doing 1, 10. So this is the unique thing about Python that we really have to keep in mind and remember. When we are declaring the number of times a piece of code will run, the actual number of times a piece of code will run is one less than the end value place. So if I do for I in range 1, 11, then and only then will hello world be printed 10 times. Likewise, if it's 1, 15, then hello world will be printed, in this instance, in this example, 14 times. So we have to keep that in mind, okay? So using I, like I mentioned earlier, it's the count-controlled variable that we use. It's a variable that we're using as a counter to do something called iteration, iterating through the process. Iterating through basically means going through, looping through, repeating through. They're all synonyms of each other. And that I can be used in many ways. In this case, we're doing for I in range, print I. That means what we're doing is we're using the I variable, which we've declared in our for loop. And this is very important, by the way, regarding declaration. Unlike where in the past where we were doing, so let's say, x equals 5 beforehand, when we do for I in range or for x in range or for whatever value variable name you want in range, that variable name is declared in the for loop and in the for loop only. You don't have to declare that variable previously. In fact, you shouldn't, because you're actually creating a new variable when you are launching that for loop. So the I is, in this case, a counter, and we're printing I. Like I said earlier, 1, 11 means it's going to be printing 10 times. In this case, 1 to 10, because we're printing the I value. So I value actually never goes up to 11, it goes up to 10. The 11 is the upper bound, and the upper bound value should be 1 greater than the maximum I value that we want to output. So now we've talked about a count-controlled loop in the case of a for loop, and that for loop is so important when we know how many times something is going to run in advance. But what if we don't know? And what if we want a condition? That's where a conditional loop, like a while loop, comes into play. So a conditional loop, unlike a for loop, is sort of like an if statement. Now, why do I say that? I say it because in if statement, as we learned in a previous lesson, the piece of code inside that statement will run only when the condition present and condition stated in the if statement is true. Likewise, the same is true for a while loop. In a while loop, while a certain condition is true, the code inside that while loop will run. And once that statement becomes false, you will no longer be running that loop, okay? Meaning that it's a conditional loop, as I mentioned earlier. In a for loop, you don't have to have a condition. In fact, you don't have a condition. What you're rather doing is running a piece of code, set number of times, being there, done that. There's no condition in the for loop. Now, you can have nested if statements, which is basically where you have an if statement inside your for loop. That is possible, and we will see many examples of those in future times. In the context of a while loop, we're executing a set of statements as long as a condition is true. The condition we've stated after saying while. So in this example, we say I is 1. While I is less than 6, we first print I, and then do I plus equals 1. So before I get to the I plus equals 1, what we're essentially saying is, because I is 1 initially, the loop will first run. Makes sense because 1 is less than 6. We then print 1. Now I plus equals 1, what does that do? I plus equals 1, or x plus equals 1, or whatever variable name plus equals 1 or plus equals 2, is a method in Python to increment. Increment means increase the value. In this case, we're doing incrementing by 1. We could also do I plus equals 2, which would increase the value by 2 each time that particular iteration happens in every single instance, right? That increment will be always constant because we've said I plus equals 1 or I plus equals 2. But what that means is, eventually, because we're increasing the value of 1 each time we're printing the I value, eventually, I will no longer be less than 6. In fact, will be greater than 6 eventually. So we have 1, and it gets to 2, then it gets to 3 for the I value, and 4, then 5. Once it gets to 6, this is an interesting thing you have to keep in mind. It's then asking, well, 6 is less than 6. Well, if 6 is less than or equal to 6, then it'll be a different story. But because the 6 is less than 6, the condition is still false because 6 can't be less than 6. So again, the code inside the while loop is run. And then 6 becomes 7. And once I becomes 7, 7 is no longer less than 6, meaning that the condition set in the conditional statement in the while loop is actually false then, meaning that the while loop then no longer runs. Now, this is an important thing to note for while loops. We have another concept called break statements. I briefly introduced this concept in the previous lesson, but let's go over a bit more to get a more in-depth understanding. So the break statement, we can stop the loop even if the whole condition is true. What it means is it's basically an exception case, okay? And the exception case works by saying that, in this case, if I equals 3, so once I gets to 3 after incrementing the I value by 1 each time, we break out of the loop, meaning that I will actually never get to 4, 5, or 6. I will be less than 6 because 3 is less than 6, but I will never get to 6 or 7 or 1 because we're breaking out a statement immediately as I equals 3. That is the case. And note the use of colons and the use of indentation. I've talked about indentation previously, which is where you use the tab key on your keyboard to indent your code. And it's really, really important because if you don't, then Python doesn't know what's inside the while statement, the while loop. Because if you don't indent a code, Python actually thinks the while loop's empty. You obviously don't want that because you obviously have code you want to have inside your while loop. Right. And the use of colons, like in if statements, like in for loops and whatnot, you do need your colons. See? Go back to your for loop. Using your colon. Okay. So now we've talked about conditional statements where there's a certain condition and it runs only when that condition is true. But there's also a different type of while loop, and this is called a while true loop. This creates an infinite loop and it needs a break statement, otherwise it will crash the computer, because if there is no break statement, then it's going to always run infinitely, and eventually, yes, it will crash the computer because you're using so much resources of the computer. Always. Because there's never an opportunity without a break statement, if you don't have a break statement, to get out of the loop. So that's why you need a break statement. And the break statement is basically whereby you break out of the loop once a certain condition that you set inside the while loop is true. So in this example, you must have a if statement inside the while loop instead of having the condition be while x is less than 6 or whatnot, which you type usually in a normal while loop after saying while, right? After typing up while. So in this case, we see x5, that's the declared x value, while true, so it means it's going to infinitely run, until if x is greater than 10, then print x is now 10, break. Else x plus equals 1. Meaning that what this code essentially does is starts with 5, the x value, becomes 6, becomes 7, becomes 8, becomes 9, becomes 10. Still not true for the if statement. 10 is not greater than 10. So again becomes 11. Then immediately, when x is greater than 10, which is true when x is 11, it prints to the console, x is now 10. It breaks out the loop, meaning that now the infinite loop has been stopped from executing. So first question here, write code that prints out all the numbers from 1 to 100 and prints out whether they are odd or even. A hint for this is that you basically have to use a for loop, a count control loop, because you know how many times the code is going to run because we're printing from 1 to 100, and print out whether they are odd or even. And that odd or even concept comes with the use of a conditional statement using modulus, which is what we talked about earlier, whereby mod 2 equals 0 means it's even, mod 2 equals 1 means it's odd. And write code to output some of the first 20 even numbers, again, count control loop in use there. Another example question here. Again, one thing to note is that these questions are all example questions. If you want the answer to them, please post them in the comments below, your questions, and we're more than happy to provide answers. For now, because of space, we have not been able to do that. So write code to output the first 10 times table, take user input, and so on and so forth. So this requires a user input, and then either a for loop or a while loop, depending on how you approach the problem. And an interesting problem that I included is that write code outputs the first 30 terms of the Fibonacci sequence. The Fibonacci sequence, to recap, is 1, 1, 2, 3, 5, so on and so forth, whereby after 1 and 1, the third term, for the third term onwards, you're adding the previous 2 terms' values to get the next term. And question 3, write code that outputs all numbers from 1 to 100 and checks if each number is a perfect square. Perfect square is like 1, 4, 9, 16, 25, so on and so forth. They're all square numbers, the proper square numbers. And like in previous cases, with questions 2 and 3, we talked about square number sequences, like I said, 1, 4, 9, 16, 25, and Fibonacci sequence, 1, 1, 2, 3, 5, 8, and so on and so forth. And at some point, these two sequences do overlap. In the case of the fourth question, we're therefore asking is to write a code that basically gets these two sequences, so you're using a count control loop, and use a while loop to try and find where these two values intersect, where these two sequences intersect, and what values. And this is an interesting problem. It's a hard problem. If you need help, post in the comments below. We're more than happy to then help wherever possible. Thank you for watching. Please like and subscribe if you want to see more of our content. This is Deep Saha, signing out.